Hi, in this lecture you learn how to use a HC-SR04 ultrasonic sensor, which is a very popular sensor in the Arduino world that helps us create projects that require some sort of distance sensing. For example, the ability for your gadget to figure out whether there is something in front of it and how far from the sensor that object is. You can think of this ultrasonic sensor as a sort of a radar. But instead of using radio waves, it uses high frequency sounds, ultrasonic sounds. In this photograph, which I took a little earlier, you can see the ultrasonic sensor module directly attached to my Arduino Uno. And I thought I'd show you how to do that and how to use this method to draw power from one of the regular digital input-output pins instead of the 5-volt output pin that we've been using so far to power external modules. Now in this lecture, I'm only going to do a quick demonstration of how to use an ultrasonic distance sensor. But if you want to learn the details, I encourage you to have a look at Arduino Step-by-Step Getting Started, where I have an entire section dedicated to sensing distance with the ultrasonic distance sensor. So here you learn about the principles of operation of the ultrasonic distance sensor, the wiring. I also got a demonstration where I show you on my oscilloscope what the signal that is coming out of the ultrasonic distance sensor looks like and how it changes depending on what it is that it is detecting in front of it. Now, as far as this sketch is concerned, in Arduino Step-by-Step Getting Started, somewhere around here, lecture 510, you'll see my demo from that lecture. What I've done in this lecture is to make a few simple changes to the trigger pins and the echo pins, and I've added one more pin, as you can see here, so that I can attach the sensor module directly onto the Arduino Uno instead of having to use jumper wires and a breadboard. So let's continue on my bench first. I'm going to show you what the hardware side looks like. Then we're going to come back and have a look at the sketch, upload it, and see it in action. Now let's have a look at the sensor module and how I've connected it to the Arduino Uno board. So you can see here it's already assembled. There's no wires. I could have alternatively used my breadboard and a few jumper wires to make this connection possible. But I wanted to try something different this time. So I'll turn it around so you can take a better look at this. So you can see here that I have attached the ultrasonic sensor module so that its GND pin is connected to the GND pin on the long Arduino Uno header. This one here is a digital inputs output pins header. Then I've got the echo pin on the module, which is connected to digital pin 13. And therefore then the trigger pin is connected to pin 12 on the Arduino Uno. And finally, the power input pin for the module VCC, instead of being connected traditionally to the 5-volt pin on the Arduino Uno, this time I've connected it to digital pin 11. And the way that I'm going to provide power from the Arduino to the module is to turn this pin into digital output and then write the high value to it. And that will provide 5 volts to the module. It's not going to be able to provide too much power, but for the purposes of powering this simple module, it doesn't draw too much power. What the Arduino can provide through the digital output is enough. Of course, this method would not work for something that requires more power. For example, a servo motor. In that case, you would need to use the 5-volt pin from the Arduino Uno. But for something light, such as this sensor, the few milliamps that come out of the Arduino's digital pins, when configured as outputs and set to high, is enough. And we'll see that working in a moment. Now, if you're following the schematic from lecture 510 of Arduino Step-by-Step Getting Started, just notice that the pinouts here in the schematic are slightly different. So I have connected echo to digital pin 12, trig to digital pin 13, VCC goes to 5 volts, and ground goes to ground. So if you prefer to use this method with a breadboard, not a problem at all. Just remember to adjust your sketch accordingly. So I've oriented my sensor like this, and I'm going to use this PCB as a target. So we're going to use this target to see how sensitive the sensor is. And in the output on the Arduino IDE's serial monitor, we'll be able to see how many centimeters away from the sensor this PCB is. So to help us with the measurements, I'm going to use this ruler. All right, let's have a quick look at the sketch now. So here's the sketch. It's slightly modified from the original. You can see here, this is the original from the Arduino step-by-step getting started GitHub repository. You'll be able to find the modified version in this courses repository, which at the time that I'm recording this video is not yet ready, but you can see the URL or the link to this sketch on the courses GitHub repository on the screen now. So small modifications. First of all, I flipped the trigger and echo pins. So for our experiment, trigger pin is 12, echo pin is 11, and then the power pin, as I said, instead of connecting power to the 5 volt pin on the Arduino Uno, I'm connecting it to digital pin 11. In setup, I prepare the serial monitor to operate at 9600 boards, and then turn the trig pin into an output, the echo pin into an input, and the power pin into an output. And to provide the necessary 5 volt and the few milliamps that the sensor needs, I'm using digital write on power pin to send out a high signal, and that will send 5 volts on the power pin. Then inside the loop, I am declaring the duration and distance variables. And here in lines 59 to 63, I am creating the trigger. Basically, this is the ping that the sensor will emit for it to bounce on the object in front of it, come back, and then measure the amount of time for the round trip. So this ping requires a low followed by 2 microseconds, followed by a high for 10 microseconds, and then back to low. That's the trigger. That's the ping essentially in the sonar. Then we use the pulse in function to measure the amount of time that it takes for the signal to bounce off a surface in front of the sensor and return to the receiver of the sensor. And this is a formula that we use to calculate the distance in centimeters. Again, if you want to know how this formula comes up, have a look at the lectures here in Arduino step-by-step getting started, where I explain how this formula comes about. And because there is a limit to how far the sensor can see, that limit is around 20 centimeters, then I've got a if statement so that if there's nothing detected, it's probably out of range, just too far. Otherwise, we'll print out the distance in centimeters. All right, I'm going to upload this sketch and see it in action. All right, let's turn on the serial monitor. Okay, there's something detected in front of it, but it's probably me. I'm going to use my target. I'm now standing aside from the sensor, so to make sure it's not picking me up. And let's see, I'm going to place the PCB, say, around here. And the output is 6 centimeters. It's a little bit more. Oh, okay. It's a little bit more because my ruler is not positioned properly. So around here, you can see the edge of the ruler is about the edge of the sensor's casing. There's a little bit, let's say 7 centimeters. And yeah, it's a little bit off, I think a little bit off, which means that I can adjust the formula a little bit more in order to take account of this offset, but it's actually pretty close. So I can see 7 is right there. I'm going to move my PCB a little closer, let's say over the 5 centimeter mark. And you can see, yeah, 4, 5 is just oscillating between the 4 and 5 centimeters. But I think this is pretty good accuracy for a sensor like this. And you can see how the reading changes fairly quickly as I am moving the target back and forth. So later on in this course, we'll use this sensor to provide a basic safety feature to our Arduino remote control car. We'll get the car to use a sensor to detect an obstacle in front of it, and once an obstacle is detected within a certain distance, we'll get the car to stop automatically and avoid a collision.